Hello, welcome to week 8 of Algebra 2 Accelerated Distance Learning Style. Pretty crazy. We're in week 8 of the school year. We only got a couple more weeks left, so let's finish strong. Let's really try to finish strong. I know that it's hard with the different grading scales and different information on how you will be graded or not graded coming out from the district. It's been hard maybe to stay motivated or think it's worth your time to spend on Algebra 2 Accelerated. Now, I know that math is not your whole life. I'm not kidding myself, right? For a lot of you, math is the last thing on your list, which you get to make that decision. I still respect you as humans if you make that decision. But I want to remind you that if you're continuing on and you want to be prepared for college level math, so if you're pursuing any kind of a career that has to do with engineering, with science, with medical field, computer science, computer engineering, many different areas that involve higher level mathematics, it's going to be really worth your time to put in the time now to lay the foundation of your understanding of these concepts. So next year in pre-calc or in other classes that you're going to be in good shape. So along with that, I want to remind you that I'm here to help. And so anytime, I'm happy to make extra videos, and I'm happy to do a Google Meet with you one-on-one, and I'm happy to send emails. So just keep reaching out to me. Something that's kind of nice is that this week we have kind of a simple task ahead of us. It's almost exactly the same as last week's lesson. The only difference is that we're no longer talking about cosine graphs, we're talking about sine graphs. And so there's just like a quick little difference between them, but other than that, same exact concept. So hopefully you won't have to put too much time or effort into understanding this. This week should be a little bit of an easier week for you if you put some effort in last week. All right, let's get started. Just to take note that today we're doing 9.4, graphing cosine functions. And oops, this should say cosine. See, it's exactly the same. I just copy pasted, changes sign, just cosine, forgot a couple. Oh well, should say cosine functions and marking the 5 key points. And so this is the same thing we did last week. I created a Desmos website for you to check your answers, to try the different slider values. And so I would encourage you to pause right now and take a look at that slider image of a cosine graph, just so you can familiarize yourself with maybe what's the difference between a sine and a cosine. So go ahead and try it. Pause your screen now. I'm going to do the awkward thing that I do. It takes me a second. My screen. Okay, see you in a minute. All right, let's take a minute and look at the website that I created for you guys to use. So this is just coming in. If you didn't look at this last week, just so you know, we have the K, the A, the B, and the H values all written out here. And then these 5 blue dots are the 5 key values. And so we can change our K value. Remember, that makes the whole graph go up and down. And we can change the A value. That changes the amplitude, or how tall or short the graph is. The B value makes the period either longer or shorter. And I can zoom out a little bit to see that a little more clearly. So if it's a less than 1, it gets bigger. Your cycle, if it's more than 1, then your cycle gets shorter. And then your H value makes it either move to the left or the right, depending on if we are negative or positive for our h value. So exactly the same as what we've seen before. Something that you might notice that's different, though, is that instead of having our first blue dot be in the middle, like down here, it would be up here at the top, right there. So let's get this back to neutral. Remember, you can always just refresh the website and it'll send you back to all neutral values, which is really helpful when you are trying to check your answers. So yeah, as you can see, normally the sine graph would be starting at the k, but with a cosine graph, it starts at the maximum, goes down to the minimum, and then goes back up to the maximum. Same symmetry, right? You're still cutting it into 4 pieces. Same exact symmetry. It's just you start at the max instead of starting at the neutral middle line. Okay, so let's take a look at our notes and go through the rest of our notes to see what's up with that. Okay, here we go. We're gonna go through the unit circle. So just for fun, go ahead and pause and see if you can remember the unit circle. It's from 2 weeks ago. Remember, due dates are open, so feel free to go back and do it if you haven't yet. All right, now I do that awkward thing where I have to pause, and I'll be right back, and I'll let you know how many minutes it took me. Okay, I did it. I'm pretty proud of my time. Got under 3 minutes, and this time I actually did all the radians and degrees and all the points. So pretty proud of myself. Let's see if we find any mistakes along the way as we go through. And we're basically going to do the same thing we did last time with sine, but with cosine this time. All right, so let's get this out of the way. We don't need to see my time anymore, even though I'm super proud of myself. You know, it's fun. Challenge yourself, even if you're an old math teacher like me. Okay, so let's go through. Remember from when we were learning about where does the unit circle come from and how do we know all these coordinates? It's from special triangles, and we knew that the opposite over the adjacent, or sorry, opposite over hypotenuse, that's sine, but adjacent over hypotenuse, that's cosine. And so cosine is the x coordinate of the points all the way around. So we're only going to be looking at the x coordinate here. So bye-bye. All the y coordinates can go away. Get that gone. Oops, wrong one. Ah! Okay, there we go. So now erasing everything that's not the x coordinates. So that would be these guys. Oop, got to be careful. Make sure that I get all of these y coordinates. Goodbye, goodbye. That was sine. That was last week. We don't need you anymore. Other thing as well is that we're going to be dealing with radians only when we're graphing. So we're going to erase all the degrees just to make it a little bit more clear. So we don't have a bunch of extra information that might confuse our thinking. Goodbye, degrees. Goodbye. Don't need you. Don't need you. So remember, the function is like an input and an output. There is an input of radians, right? An input of an angle. And then the output is the exact value of the x coordinate on the unit circle at that point. So let's take a look. The radians as we go through, and let's just do the first coordinate first. We have a radian value of 0 there. And then our x coordinate at that point is 1. So notice how when we were doing sine, right, this was here, we were looking at the y coordinate. We started at 0 for sine, but for cosine, we're starting at 1. That's why when we looked at the graph, instead of having the sine function, right, the sine function looks like this, where you start at the middle point, or 0 if we have all neutral values. Instead, it looks like this, where it's the same cycle, but we're starting at the maximum, which is here on the sine graph, but it's at the start for cosine because cosine starts at 1, or the x value starts at 1. All right, so let's fill in the rest of the stuff. Not as much explanation. Again, if you want to skip through this, you don't have to watch me go through all the points. But if it's helpful to you, stick around. We're going to go through every single part. All right, so the next point is pi over 6. and that's root 3 over 2. So we're coming down, right? The x value started at a maximum and it's moving in towards its minimum. This would be pi over 4 next, and that's root 2 over 2, which is slightly less than root 3 over 2. And then the next point is pi over 3. That has the value of 1/2, even less to the right? A smaller x value means you're closer to the y-axis. And then finally, pi over 2, we're back at 0. So we're at a maximum, we're going down to 0, instead of sine, which starts out going the opposite direction. Let's keep going. Next, we got 2 pi over 3. That x value is negative 1/2. Then we have 3 pi over 4. If we scoot over a little bit, we can see that's negative root 2 over 2. Negative root 2 over 2. Next one, 5 pi over 6 is at negative root 3 over 2. So that's 5 pi over 6 is negative root 3 over 2. And then finally, at pi, we're at negative 1. So we're at the minimum of our graph. So pi negative 1. And then just like the sine graph, the cycle repeats, but it just goes the other way. So after pi, our x value was at its lowest point, which is on the left-hand side. I'm not sure if my camera mirrors. So we're all the way on the left-hand side, and then we're going to slowly move in towards our minimum or our 0 value. All right, so this is 7 pi over 6, 7 pi over 6, and then we can see that's negative root 3 over 2. The next one is at 5 pi over 4, and that takes us to negative root 2 over 2. We have 4 pi over 3, and that's going to take us to negative 1/2. And then finally, we're at 3 pi over 2, and that takes us back down to 0. So we're kind of following with the x value in the unit circle. We start off all the way to the left all the way to the right, and it brings us into the middle at the y-axis where we're at 0. Then we go all the way to the left, which takes us all the way to negative 1. We're on our way back. We're going to 0 now, and we just have to finish off the cycle by going to positive 1. So here our next value is 5 pi over 3, which is 1/2. And then we have 7 pi over 4, which is root 2 over 2. Then we have 11 pi over 6, which is root 3 over 2. And then finally, at 2 pi, we are at 1 again. We're at the maximum value. Okay, so how do we translate this into a graph? Remember, we're not going to graph every single point because we know that the points in between are just kind of, it gives it the shape, but the most important points are these ones that are highlighted in green in the table. They are called the key points, and you have to list the key points when you are graphing in order to show you really know what the graph looks like. So the key points are all these points on the way around the circle. Oops, gotta redo that. Okay. And then need a big one. Okay, so there are these key points all the way around the circle where we have our maximums and our minimums and our neutral in the middle of the symmetry points. Usually 0 when we have neutral values, but as we change the k value, that neutral value kind of tends to change. Okay, so let's draw our graph. Let's start. At 0, we can see the k value, and I'll change colors just so it's a little more clear. We can see here for our 0 radians, we have a value of 1. So that's going to be our maximum, just like on a sine. We can mark the minimum too. And remember that when I am graphing, I like to make a little path so that my symmetry stays a little nicer. So that first point is at 0, 1. All right. Our next key value is at pi over 2, 0. So that's this point right here. And so if we mark this is pi, and then halfway between is pi over 2, and then halfway between that is 3 pi over 2, we're going to be at the 0 line at pi over 2. All right, looking at our next key point, we're at halfway around the circle and it's our minimum, right? It's all the way to the left. So that's the smallest x value where you're going to get. That's going to be down here. It is at -1. All right, our next key value is at 3 pi over 2. That's 3/4 of the way around the circle. And we can see it's at 0, our neutral value on the y-axis again. So that's that point. And then finally, we're at 2 pi, and we're back up to our maximum again where we started. And the graphs look exactly the same as a sine graph. Something that it's a little harder, I think, to draw a cosine so it looks nice. But most common mistake I see is students will go like this. It's not like a pointed thing. It's not a V, right? It needs to be curved. So we need to make sure that we're trying to get better and better at like coming down, curving, and then curving. Almost like a parabola shape rather than a triangle shape. Again, don't worry, it doesn't need to be perfect. You're not turning in anything that even has your pictures on it, but for next year, for pre-calculus and your math career beyond, it's good practice to make sure you're trying to make these look as smooth and connected as possible. All right, y'all, this next thing should be, it's exactly the same as what you did last week. So leave it up to you. You want to just pause the video and try these and then check your answers with me as I go through. Feel free. If you want to go along with me as I go through more and more and more examples, also awesome. So I just want to make sure that you know that although my videos get really long, I just make them as long as I feel like I can possibly make them, just because I want to give you extra examples. So never feel like you have to watch the whole thing if you don't need to. Okay, let's keep going. Let's do some definitions just to remind us from what we did last week. Cosine function in general form. So here's our general form of a cosine function. Just like we've seen like standard form quadratic, vertex form quadratic, standard form, general form exponential function, lots of different formulas that for functions. So it's called a periodic function because it repeats cycles. So remember, periodic functions are things that will go on forever just because we can keep going around the unit circle if we wanted to. We could keep going and the pattern would still be the same every time. So that's why they call it periodic functions. And we use the angle theta as our input, and the output is the f of theta. A little confusing because that's the same thing as with sine. And when we talk about sine and cosine, we think about it as x and y, and that can be a little confusing, but we're just going to focus on the shape of cosine, input a radian, output a value, a cosine value. All right, and then these 4 letters represent the 4 different changes that you can change a cosine function. The first change is the vertical shift. Remember, it's important to do the changes in this order to make it easier to get your function correct, because otherwise you might, if you do it out of order, it's a little harder to stay organized. So this moves the graph up and down. You're going to draw a line at y equals k to indicate the center of our graph. So that's that, when we were looking up here, that's that twine that we had right here. That is the angle, is the middle line. And the k value makes it go up from 0. Remember, this middle line was 0, and go down. So if I had k equals 3, it would be up to 3. If I had k equals -1, that middle line would go down to -1. We'll do some examples of that. Amplitude changes depending on, amplitude changes the height of the graph, how high the maximum is, how low the minimum is. So for example, in this picture, we know the amplitude is equal to 1 because the distance between the middle line, the k line, and the maximum is 1. And we can also see that this has a length of 1 down to the minimum. So it's not the total length, right? It wouldn't be 2. It would be 1 because it's like halfway to the middle. All right, and again, we'll do some examples. Like I said, k value neutral is 0. Neutral value for a is 1. And then, so the period shift, which is the b value controls the period. The period shift makes the cycle of the graph happen in a larger or a smaller space. And we looked at that a little bit at the beginning with the cosine sliders that I have in Desmos. But you need to plug in B to this formula in order to get the period. And this was one of the most common questions I got last week was, I don't understand. I'm looking at this function. Clearly my B value is 2. Why did I get this question wrong? Well, if your B value is 2, that controls the period. So you would say 2 pi over 2 if your B value is 2. And then you would say, okay, well, that simplifies to pi. So the period is pi. The B value is 2. So careful, there's some questions on your formative and summative about that, and some people were tricked last week. And then finally, we have the phase shift, which, depending on your other values, can be the trickiest part. But this is what changes you to the left or the right. It takes all 5 points, and it says, okay, I'm going to move you to the left, or I'm going to move you to the right. When we have a neutral value for h, we're at 0. But looking back up at it, this graph is like all neutral values. This is just plain old parent function cosine. But if I were to have like a value of pi over 4 for my h value, then I would need to move every single point over pi over 4. So it makes everything shift over whatever that value is. Now, the confusing part about the h value, extra confusing part, is that the h value, you notice in the general formula here, has a negative in front of it. So that means if I said the h value was positive pi over 4, it would look negative because I'm plugging it into the formula that already has a negative in it. And similarly, if our h value was negative pi over 4, when I plug negative pi over 4, when there's already a negative there, it becomes positive. So it goes the opposite direction that you would think when you're just looking at the formula. So always feel free to use that website that I created on Desmos to help you check your values and make sure that you are getting the right direction and the 5 key points. Okay, so let's go through some examples. I'm going to go through these first 4. Again, if this is like, you know what, I'm just going to check the teacher notes and see if I did it right and then I don't need this whole lesson all over again, feel free, skip past this and go on. Otherwise, I'm going to do it. I love doing math, so of course, I'll just sit here and talk through problems all day long. Okay. Starting with our same strategy where we're going to write down all the different values. So k here is 2. That's where our k value is. Our a value is 1 because there's a secret 1 in front of cosine. That's a neutral a value. Our b value is 1 because there is a secret 1 in front of the theta. So again, that's our neutral value for theta, or for b. And then finally, we're looking for our h value. There's nothing being added or subtracted from theta, so that's 0 there. So that is going to be also a neutral value. So just like I did, I'm going to use green for k. I'm going to say 2 is the k value. Now the a value tells you where your maximums and minimums are. So we're going to go up to 3, which is 1 more than 2, and then down to 1, which is 1 less than 2. And then again, my strategy that I like to do is to create a little path so that my function looks a little cleaner. With a maximum and minimum. Obviously, that's not perfect. It's okay, as long as you get the general idea across and help you find your key points. All right, our b value is 1. So what does that mean our period is? It means we have 2 pi over 1, which is 2 pi. So again, that's a neutral value. 2 pi is a circle, a normal circle. So that tells us our starting point and our ending point are at 2 pi. So remember that since we're dealing with cosine, our starting point and our ending point are both maximum. They're both at 1 if it's a neutral value, but in our case, 3. Now we're going to use symmetry to, didn't do the last one. So the last one is h equals 0. So that means we don't have to shift anything to the left or the right. So we don't have to do anything with that. So symmetry, remember halfway between, we're at our minimum. Halfway between those, we're at 0. And that's the same for every single cosine graph. So as long as you're able to do first, last, middles at the minimum, and then the middle k value is in between those, you're all good. So let's try and make this as good as possible. Let's see. There we go. Crushed it. Looks pretty good. We didn't have to do anything too hard for that one, but let's just, so you know how to use the website that I created to check your answer. Let's check an answer. Why not? All right. You can always skip it, right? If you're if you don't want to. So I'm going to press reset or reload because that'll take me back to all neutral values. And then I'm going to change my values here. My k value is 2. My a value is 1. All the rest of them are neutral, so I don't have to change anything on all the other ones. And then, oh, I'm on the sine graph one. Oops, I want to be on the cosine one. There we go. All right, let's try that again. So let's change k to 2. That's the only thing that has changed. And then I'm just checking my values. 0, pi over 2, 2, pi 1, 3 over 2, 2, 2 pi at 3. And that's the same as these. So I'm going to write in my values. Almost forgot. 0, 3, pi over 2, 2. That's what the graph I used to check my answer said. So I'm happy with what I'm seeing. 1 at pi. Again, back up to 2 at 3 pi over 2. 2. And then up here we got 2 pi back at our beginning at 3. All right, so let's keep going. Got tons of examples to do. This next one, notice that the only thing that is changed is the amplitude. So let's go through. We got k is equal to 0 because if you put a plus 0 on the end, it would still be the same. So that's our neutral value. We have an a value of 4. You can see that's highlighted in yellow. We have a b value of 1. That's because there's a secret 1 in front of the theta. And then we have an h value of 0. That's because if you added 0 to theta, nothing would change. Let's get after it. So k is at 0, so we just put a 0 there. We have a value of 4, so that means we go up 4 and down 4 from there. B again is 1, so that means we have a b value that is means we're at a normal. See, this is why I like having the little path. We have a normal period, and then since h is 0, we don't have to worry about shifting anything left or right in order to draw out our final graph. So let's use symmetry. So halfway we're at our minimum. Halfway between there, we're at 0. Halfway between the last two, we're at 0. And then we just do our best to draw a beautiful graph. Not perfect, but that's okay. Here, we're at 0, 4. Here, we're at pi over 2, 0. Here, we're at pi negative 4. Here, we're at 3 pi over 2, 0. And then finally, we are at 2 pi 4. All right, looking pretty good. Let's go on to the next one. Next one, notice the only thing that's changed is the b value. So let's keep that in mind. We have k is equal to 0 again, because if you add k, it's adding 0, so nothing has changed. Our a value is 1. Again, that's because there is a secret 1 in front of the cosine where the a would be in the general formula. And then the b value is 2. That's a little different. We'll do that example together. And then finally, h value is pi. Oops, I was looking at the next question. Is 0 because nothing is being added to the theta. So K value at 0 means we put a 0 there. A value of 1 means we go up 1 and we go down 1. And then I'm not going to make that same mistake I did last time. I'm going to actually draw a little freeway to drive my cosine graph on. And then finally, we got a B value that is 2. This is 2 pi over 2, which would be pi. So what that means is you're going to start at 1 like normal, unless the h value was not neutral. And then we're going to end this time at pi. So symmetry is still the same. Oh, yeah. And since h is 0, we don't have to move any of our points. So we don't have to worry about that. So halfway between 0 and pi, we're at our minimum. Halfway between there, we're at 0. Halfway between the last two, we're at 0. And so it's the same shape, just squished into a smaller area. Okay, so let's go in and do our points. This one would be 0, 1. This one would be pi over 4, 0. This one would be pi over 2, -1 down there at the minimum. Then we have 3 pi over 4 at 0, the middle line. And then finally, pi is at the maximum again. So I know, skip this if you want to. I'm going to check the answer to this using the website that I created one more time. So K is no longer 2. It's at 0. Our B value is 2. So I'm going to put in 2 here. And then I just click these points to make sure that I got the same answers. Yep, I got all the same answers, so I know my answer is right. Okay. Let's go back. And last one for me before I give you some time to try your student examples. So last one here, it says that the K value is still neutral. The A value is still neutral. The B value is neutral again. And then our difference here is that our H value is now pi over 4. Notice in the equation it looks negative, but it's actually positive because the general formula has a negative already. That means that value is positive. All right, so let's start. We got a K value of 0, so that means that's 0. We have an A value of 1, so that means it goes up 1 and down 1 from that middle line. And then B value is neutral again, so that means we're at starting there and ending here. And now here's, we need to look at our H value. So I'm going to put in all the points just as I would if we had 0 for H. Like that, everything we're used to. And then with the H, I know everything bumps over pi over 4. So I'm going to move all these points over pi over 4. Because we're adding pi over 4 to the values. Okay, so now we have this little bit different spot, but it's still the same shape, still the same exact symmetry. Everything should be the same. So now instead of being at 0 for our first key point, we're now at pi over 4 because 0 plus pi over 4 is pi over 4. And then for our second key point, we would have been at pi over 2, but we added pi over 4 to that. So we're now at 3 pi over 4, and that takes us to the 0, right? The middle line. And then we would have been at pi, but we added pi over 4 to it. So now we're at 5 pi over 4, comma, -1 down there at the minimum. And then we have here, we would have been at 3 pi over 2, but added pi over 4 to that. So we got 7 pi over 4. So this should be 7 pi over 4 and 0. And then this last one's kind of interesting because we would have been at 2 pi, but now we're past 2 pi. And that would be 9 pi over 4, comma, 1, which is our maximum. Now I want to give you a hint for how could you get these values if you weren't sure what they were. Like if this wasn't written here on our graph, how would you know it's 9 pi over 4? Well, it's basically just fraction addition. So you have 2 pi and you have to add pi over 4. Well, that's just like, using an x instead of a pi. So you would say that is the same. We would turn this into fourths. So we'd have 8 pi over 4 plus pi over 4, which is the same as 1 pi. So that would be 9 pi over 4 for your final answer on that one. And you can do that for every single point. Doesn't matter what the h value is. If h is negative, you would subtract. If it's a different value, then you would use different fraction addition skills. Okay, I'm going to take a pause, and you guys are going to do your student examples so that you are absolutely certain you understand these level 1 questions. And now's the awkward part. See you back in a couple minutes. All right, hopefully you were feeling successful, or maybe you had a couple questions. Both are great experiences to have. So let's take a look at the ones that I think are going to be the most difficult for us. I think the C and D in general are the most complicated for people to understand. So let's take a look. We have question C is where B is equal to 1/2. And that can be really hard to understand sometimes, because when you plug 1/2 into the formula, right, it's this whole thing is B. Dividing by 1/2 is the same as multiplying by 2. Sorry, I wrote multiply by 1/2. And so 2 times 2 is 4. So even though it's smaller than 1, what ends up happening is it makes your period length larger. So looking back at this, what I did is I took the white pen, so I made my thing bigger, took the white pen and I erased all the things that were marked on the graph for me, and I changed them to be twice as large as they were before. So for example, like if I were to erase it really quick, let's go back to this. Okay, so if I were to erase everything that I blacked out with the white pen, you can see that instead of being 2 pi, it's now 4 pi. Instead of being 3 pi over 2, it's now 3 pi. Instead of 1 pi, it's 2 pi's. Instead of pi over 2 or half a pi, it's now a whole pi. 0 times 2 is still 0, so that stays in the same spot. So that's a really good strategy we went over last week, and so I just wanted to go over it with you again, that if you have a B value that's less than 1, it actually makes the period longer, and then it's a good idea to try to rewrite what the values are at the maximum, minimum, and the middle line, rather than trying to extend this way off. Like it's difficult to extend this that far, just with our space limitations. Okay, so this next one I wanted to point out that, I had to move it over a little bit, but when our H value is positive in the equation, it actually means you have a negative H value, because the general formula has a plus sign or has a minus sign. So it's like a double negative to make it look positive, but it's actually negative. So what that means is you need to move every point over pi over 2 to the left, which is the negative direction. And so we can see that every single point got moved over negative pi over 2, and I kind of had to create more points on my graph in order to make that happen, and so that I could show every single point. So keep that in mind, that sometimes we have to make little changes in the way we're graphing, and it can be challenging, but it's really good for our mind, and it's good practice for understanding fractions and in other problems as well. Okay, so this next section has 2 teacher problems, and in these teacher problems, I'm using the same numbers as I did in the level 1 questions, but now we're on level 2. So level 2 is our goal. That's where we want to be if we want to do well on the formatives and the summatives. However, there's one more level past that, which is level 3, which is like, that's the pre-calc level. That's the I really understand. I'm really challenging myself. So please try the level 3 questions if you want to challenge yourself, or if you're expecting to go on to pre-calc next year. Okay, so here we go. Let's do it. We're going to go through that same process again. We have K is equal to 2. No, it's not. K is, 2. Okay. A is equal to 1. our B value is equal to 2, and our H value is equal to 0. Notice how I'm picking up the pace a little bit with this first part. Hopefully you understand those parts. If not, go back and rewatch how I'm getting these numbers, one above, one below. For this one, I'm definitely making my pathway. Sorry, sometimes I forget to make that path. I apologize. Okay, so now our B value is 2, so that changes the length of our period. Remember, it's 2 pi over B, so it'd be 2 pi over 2, which is pi. Same as the last teacher example that I did. And so that means we start here, and we're going to end here, and in the middle we're here, halfway, halfway. There we go. So when two things are changed, really the process doesn't change that much. It's not, we don't have to shift anything left or right in this question, but it's just that you're doing two changes, and so you have to keep your eyes a little peeled on these examples. All right, let's label our points. 0, 3, pi over 4, 2, pi over 2, 1, 3 pi over 4, 2. And then finally, we end at pi 3, back to our maximum. All right, this next one is a k value that is 0, neutral value. And then we have a value of 4, that's different than what we've seen. We have a b value of 1, neutral value. And then our h value is pi over 4, so that's not neutral. So let's go through it. We're just following that same process. It's really going to help you not make any mistakes if you go through them in this order. Remember, our 4 is up here. Then we go down to -4 to here. Circle that in that color. Okay, then our b value is 1. That means we just have 2 pi as our period. So there, and then 2 pi. And I'm going to put in all my points there, but I noticed that my h value is pi over 4, so that means that everything gets bumped over pi over 4. And if you think it's kind of confusing to have all those arrows in there, so do I. So I tend to skip drawing all the arrows. They're more there just for me to help explain where did the point come from and where did it go. So let's draw our beautiful cosine. Oh, that's really not so beautiful. Let's draw a beautiful cosine graph. Hey, not too bad, not too bad. Hopefully yours are getting better and better. All right, and so we're starting at pi over 4, and that's at 4. This graph has a middle line at 0, so it's 3 pi over 4, 0. This one, it's 5 pi over 4, -4. Our amplitude caused our minimum to go down to -4 instead of -1 if it was neutral. This one would be 7 pi over 4, 0. And then finally, we end at 9 pi over 4, back up at our maximum of 4. Cool. So now you have 2 examples to try. So go ahead and give your examples a shot. Press pause, push yourself. You don't need to just see me do it. You don't need to just see the answers. You need to actually prove to yourself that you know it. So go ahead and pause the video and try it. Here's the other part. I'm still finding on pause. All right. So I hope that that went all right for you. I really don't think that there's anything too tricky about these because we've gone over these exact changes just one by one. So when you combine the changes, it's just exactly the same concept. So I'm going to go on to the level 3. Now, if you got here and you're like, okay, that's enough for me, Miss Jarmick. I want to stop here. I got enough on my plate. I don't need to go on, just level 3. Pause the video here. Be done. Or if you're just kind of like, okay, I've been sitting for 45 minutes or however long it's been, that's enough for me for today. You can stop here, come back if you feel like you want to try a couple of the challenge questions. But I'm going to keep going with some challenge problems. So instead of having lots of little videos, I just wanted to put everything all together in one so they're all really cohesive. Let's look at level 3 questions. They're so much fun. Okay, so we're going to start with the K value here. K is equal to 2. A is equal to 4, B is equal to 2, and H is equal to positive pi over 4. So going through this, it does make it a little trickier that there's 4 changes, specifically the B and the H. So let's do it together. K is 2, so that would be our middle line. A is 4, so that means we need to go 4 up from there to 6, and then 4 down from there to -2. And then our B value is 2. So remember, that means that we used to have a pi or a period of 2 pi, but now our period is 1 pi. So I'm going to put my start and my finish, and I'm going to put the other 2 points in here, and then my final minimum. And then I'm going to take into consideration that everything needs to shift to the right pi over 4. So what used to be here is now bumped over. Everything just kind of gets bumped over 1 pi over 4. And so there we have it. There is our final graph. Once you get down every single little change, putting them all together, as long as you follow the same procedure, right? K first, A second, B third, H fourth, that's going to make it a lot easier for you. Okay, let's label the points, and then you guys get a shot at it. So we got pi over 4 is now at 6. We have pi over 2 is at 2. Here we have 3 pi over 4 is at -2. Here we have pi is at 2. Remember, that's our middle value. It's not always 0. And then finally, we have 5 pi over 4 is at our maximum. Okay, pause the video and give your answer a shot. Yours is really challenging. Same as the way going to be challenging. So more to you. Okay, pause and we'll come back and go over it. Okay, this one was definitely a challenge for sure. So let's see. Now, I think the most challenging thing about this problem is that, okay, but look at the red points. Those key points weren't that hard to find because we've seen what happens when B is 1/2 and we have to change the numbers on the axes, the radians, to fit that twice as large. But I think the hardest part about this is that we have to then shift everything over pi over 2. And so since every single tick mark used to be worth pi over 4, instead of being worth pi over 4, we now have a situation where now it's twice as big, so it's pi over 2. And so going back to here, on your example that we saw before where we had an H value of -pi over 2, we had to go over 2 tick marks because each one was pi over 4, but now we only have to go over 1 tick mark. And that makes this a little more complicated because now we have to know that this tick mark is pi over 2 instead of pi over 4. Another way to think about this is just to say, okay, I was at pi, and I have to subtract pi over 2 to get there. I was at 2 pi, I have to subtract pi over 2 to get there. I was at 3 pi, and now I have to subtract pi over 2 to get there. And I was at 4 pi, and I have to subtract pi over 2 to get there. So one more time, I'll show you how to work through the fraction addition or subtraction. So let's do it with this where we had 4 pi, that's where we were. And then we know our H value is minus pi over 2. So I'm going to minus pi over 2. And I'm going to change my denominator so that I can actually do the addition and subtraction. So this would be 8 pi over 2. And I'm minusing pi over 2, which is the same as minusing 1 pi over 2. 8 minus 1 is 7. So hence we get 7 pi over 2. So that can be a helpful strategy if it's harder for you to just do it in your head and figure out what those points are supposed to be. All right, that's it for week 8. good luck. Make sure you're trying the worksheet and looking at the key for the worksheet. If you think there's a mistake, there's a good possibility that there is a mistake because remember, it's me. It's the way I am. I love doing math and I get really excited about it and I try to challenge myself to do it faster and tend to make mistakes. So I'm really proud of you all for sticking with this. I know it's been a hard time, but just know that I really enjoyed doing all this math with you so far, and we'll still have a little more math to do next week. So make sure you're checking in week 9. Some of your math teachers might have new assignments. I'm still deciding what kind of an assignment I want for your last week. So make sure that you check in on Schoology next Monday. Hey, you know what? If you're not checking in tomorrow, that's okay. Monday is Memorial Day. So national holiday. If we were in the school building, you wouldn't have to come in. I wouldn't have to come in. We'd get an extra long weekend. I just wanted to make sure I was getting all your materials out to you on time. So that's why you're getting this on Monday morning instead of Tuesday morning. Probably going to try and disconnect from my electronics tomorrow, but I will get back to you as soon as I can on Tuesday. So I hope you have a great rest of your day. Oh yeah, I'll do the challenge problem and post it in the teacher notes, but I like to challenge you to actually have to go to the teacher notes to see the answer to the challenge problem. All right, lovely people. I hope you're having the best time that you possibly can. Feel free to reach out to me for anything, any questions. I'm happy to answer. Miss you.